moving on from the last episode where we were chatting about the day in the life of a steam driver and stoker, and we covered quite a lot of ground in terms of how you got started in doing that and what were the pitfalls of doing that. And this time, really what I want to know to start off with is a little bit more of the technical specs on the actual railway in South Africa. So what gauges do we have in South Africa, and why were they put in place like that from the beginning?
Okay, we've got our main gauge is Cape gauge, which is either 1067 millimeters, or in feet and inches, it's 3'6". But we didn't begin that way. We began with what they call standard gauge, which is the main gauge worldwide. I mean, America and Canada and Britain and most of Europe use standard gauge. There's a bit of an urban legend in place about that. You can find posts on the online saying that it corresponds with the original width of chariot wheels, but that's been discredited time and time again. So I don't know what the truth is and how it came to be. But gauges were quite a thing back in the days when railways were being kind of invented. There were two main gauges in Britain, and the main one was that the first one, most important for a while, was by a guy named Brunel. He had a 7-foot gauge. Then Stevenson, the guy that built the rocket, the first steam engine, or not the first, but amongst the first steam engines, George Stevenson was a follower of 4-foot 8.5-inch gauge, and kind of big competition between Brunel and Stevenson. Okay, long story. You can Google it. Anybody can Google it. Brunel lost out, and Stevenson won. And I can't even remember why. It's such a hoo-ha. But we started out well in South Africa with standard gauge. We started out with railways in both Durban and Cape Town. Durban had a railway from the harbour to what we call the Point, which is kind of the nearest part of Durban that isn't on the actual bay. Well, it is, but it isn't. And then Cape Town started out with a railway, also, around about where the station is now, which went all the way to Worcester. And that was in standard gauge. But the problem in both, and with both implementations as they were then, was that you start out with what you know, if you're British, and that's standard gauge, and then you hit mountains, which Britain doesn't have many of. So the problem with Cape Town was the line went, it climbed very little in the Cape Flats and towards Hull, and then it was all climbing from then on. And in fact, those Hexua mountains were in the way, and so they circumvented those. They turned north, because the railway was going more or less west-east. And then just after Paarl, it turned north and made a gigantic U-turn right round the mountains to Worcester. So the actual distance to Worcester was twice what it needed to have been if there was a tunnel. But of course, tunneling in those days wasn't, an option. I mean, they didn't have the people to do it for a start. They didn't have the engineers to survey it for a second. They had engineers to survey railway lines, but putting down railway lines was a very easy business in those days. Sorry, I should say it was a simple business. It wasn't easy. But they did it with picks and shovels and various fairly simple equipment. But once they'd reached Worcester, and the Surveyor General had a look at Worcester, and the only route, any route to the north, were beset with huge mountains. Nothing like, I mean, I think the tallest mountain in Wales, in England, isn't as tall as the nearest mountain to Worcester above sea level. So they had to then, look at their treasury. And historically, I think the British Treasury was pretty unenthusiastic about building railways for us. Um, Beastly fuzzy wuzzies weren't worth spending money on, but their priority was to get heavy machinery to the mines and ore back from the mines, and that was all they cared about, really. They succumbed later to pressure from farmers to get branch lines to take produce to markets, but in the first place, all they wanted was to get to the reef, Kimberley and the reef, the two mining centres. And to do that as quickly as possible, they adopted the strategy of using Cape gauge. Now, what a gauge is simply the distance between the rails. So we had 2-foot narrow gauge, which was working in various branch lines in South Africa and Namibia. But the principle is the same. If you stand with your feet together and somebody pushes you from the side, you're going to have to put out a foot to keep yourself upright. But if you stand with your feet very wide set and they push you, you'll just rock a little bit and return to your equilibrium. So Cape gauge was kind of it was strong enough from a point of view of axle loading, it was strong enough to take very heavy wagons and locomotives. But because it was only 3'6", that stability issues I talked about when we stand on our feet wide set, that came into play. It was common already for the Flying Scotsman to do London to Edinburgh in less than 5 hours 100 years ago. But to this day, our speed limit on Cape gauge is 90 kph, and it's been that since for 100 years. It's just not safe unless you apply certain technological changes. It's just not safe. So, having said that, Australia and New Zealand have never really been as developed as South Africa in terms of railway technology. And there was a lot of Cape gauge in Australia for the same reasons here as terrain. And New Zealand is all Cape gauge. In fact, there are quite a few South African railway locomotives doing enthusiast trips in New Zealand. They just ship them there. But New Zealand was not as heavy rail as we. They never put in really heavy rail like we did. So, for example, some enthusiasts bought a 25 NC steam locomotive from South Africa and shipped it to New Zealand, only to discover that the axle loading was too severe on the gauge of rail that they have. And just very simply, gauges of railways are you take a meter or a yard and you weigh a piece of rail. So the lightest kind of rail would be in our old way, in our old measurements would be 60 pounds, and then there was 90 pounds, and then there was 120 pounds per yard. It's roughly the same in kilograms and meters. Now you get, I don't know what we got now. I think it's 50, 70, and 90 kilograms or something. I don't know, but because meters came in since I was in the railway. But with heavy rail, you can have very heavy axle loading, very long trains. And so, 3'6" was pretty ideal because it could take heavy axle loading, but it could also have tight curves. Standard gauge can't have tight radius curves. So 3'6" was laid in South Africa, and the Scottish engineers that laid most of our track charged by the square yard. So they went all around every hill and around every bump, and they made an absolute fortune building us railways that wound like worms around hills. And that is how we came to be and what we got. But we do have Gautrain, which is standard gauge, and we probably will be developing passenger trains in standard gauge from now on.
So now, did they need those heavy axles because the main load in those days was gold?
It was Yes, it was some kind of ore, very largely coal. They had to do a lot of coal because the coal had to be transported to the entire country for the steam engines that were pulling stuff to and from the mines. So about probably I think in the early 1900s, about probably 30 to 40% of our freight was actually from the mines to the various rail depots just to feed these hungry steam engines. But yes, coal, and then we had various other metals. But yeah, the main thing was getting ore. Not so much for gold. Gold was what you get out of a ton of ore. There's so little gold that I don't, I mean, gold bullion takes years it takes a lot of mining to produce a gold bar, probably in the hundreds of tons or thousands of tons of ore to produce one ingot of gold. So they didn't ship gold by train very much, although they did, but not very much because there's very little of it coming out there. But there were various other things. The ore, what they dug out of the earth went straight into making mine dumps, which are all gone now. But yeah, I mean, for all the other mining, it was more to get heavy equipment to the mines and back for to where it gets. So to cut that long story short, we didn't really have engineering works in the mining cities. So machinery was shipped was railed back to Cape Town and railed to other places to be serviced and maintained. And that was the purpose of the goods trade. And then only later did it become an agricultural need, where the farmers need to get produce to urban centres.
And so, with the speed being capped at 90, you were mentioning that was dangerous, and is that because of the cornering on those really winding tracks?
Sort of yes and no. It's not strictly speaking true that trains will derail from speed with our existing tight curves, but it partially is that. The other thing is that if you look at any steam engine, it's got four driving wheels, and they're in a straight line. And they only get around curves because the wheel is wide, and the wheel mounts the rows to different degrees. And so you've got a straight locomotive of four sets of wheels in a straight line, probably 3 or 4 meters, and it creaks and groans its way through curves if they're very tight. So that the problem with 4 foot 8.5 inches is that you can't trains can't navigate, they can't negotiate tight curves, but they can with Cape gauge, if the wheel sets are closer together. So, but in terms of the question that you asked about stability, the perception of passengers, and I know this from first hand, the perception of passengers when a train hits a safe 40-kilometer bend, say 40 kilometers per hour, but hits it at 60 kilometers per hour, is it's just the centrifugal forces is too nerve-wracking. I mean, your drinks spill if you're at a table, or if you're sitting on a bench, you slide right across the bench onto the floor, possibly, if you're in that kind of carriage. So it's the cornering force that was unacceptable to passengers. And of course, if they were sleeping on a bunk, if they went around one way, then their head would hit the wall of the coach, or their feet would hit the other wall, keep sliding on the boat. So it was partially, it's a 50% of the experience of cornering force was unacceptable, too frightening to passengers. When I say I speak from personal experience, I had a very crazy driver in Zululand who used to take safe 30 kilometer per hour curves, very tight curves, at 70 kilometers per hour. We never came off, although it was close ones. But the passengers started bailing. They started climbing out the windows and jumping out the train. It's very frightening for passengers. So, as I say, it's 50% an engineering issue, a stability issue, and 50% it's not acceptable to passengers to get that degree of cornering force.
So then, presumably, even though modern trains have smaller wheels and they're not dealing with, those four big wheels of a steam train,
Yeah.
uh, those forces going around the corners are still what's keeping that speed limit at 90. Would you say that was fair? And what kind of technology has changed to kind of mitigate that over the years?
Okay. Well, of course, the first and greatest change was abandoning steam for diesel. Steam, from an engineer's point of view, steam wasn't efficient. It was no more than 15% efficient, usually about 8% thermally efficient. As uh, if you take if you take a gallon of fossil fuel equivalent, I don't know how many tons of coal that is. Probably about a ton or half a ton. It uses a lot of coal compared to a diesel, and expressed in other ways, let's just say a train will do 10, 100 meters on one fossil fuel gallon equivalent. Well, a diesel would do two or three times that, and an electric 4 or 5 or 10 times that. So yeah, they were inefficient. And then that was the main technological change, was the change over from steam to other forms of traction. With that came, as you say, smaller wheels, the tractive wheels. Steam traction was always 4 feet or greater, and currently the wheels are down to about a meter in diameter, a little bit more or a little bit less, but around a meter. And they're covered in, and they are, and all of the trains these days work on what they call a bogie, a set of bogies, which is like a truck, but 4 wheels. A bogie is basically a 4-wheel truck, and it's 2 wheels and 2 wheels mounted on a table, and that's hinged and turns at the end of the carriage. And the technological changes, since you ask about them, have gone well beyond that. We've now got all of the high-speed trains in the world have got steering bogies, because if you hit a curve at 200 miles per hour, there is a tendency for the flange on the wheel to mount the rail and just go straight over. So you want that to turn with the rails. And they have now, the first steering bogie was invented by a South African railways engineer named Herbert Scheffel. And that was the reason why we have the world speed record for Cape Gauge of 245 kilometers per hour. We actually drove a train at 245 kilometers per hour with no computers, no help, just a guy driving a train at 245 kilometers per hour. I think he did between 2 and 8 kilometers at that speed. And it was rock steady because it was straight. There were no curves. And then we built this train called Metro Blitz, which used those steering bogies, and that flied the route between Pretoria and Johannesburg. And it took only 2 minutes more than Gautrain does on standard gauge today. So, that shows you that it's more. What's changed technologically is there's an imperative about the condition of your track. The TGV and the bullet trains make the slowest curves possible, no tight curves. Tunnels and bridges and straight, very, very slight curves. They can negotiate those curves at 200 miles an hour, and they still need steering bogies for that. And of course, um, the gradient where South Africa started off from Durban to Maritzburg in actual straight line distance is 35 miles, but it's 50 miles by road. Getting to getting to rail, it was 50 miles by road and I think 88 miles by rail. just because it went around the Valley of a Thousand Hills and engineers made a killing. But the thing is that you not only is it only 35 miles, which is basically 75 kilometers, I think, but Maritzburg platform is at 218 feet above sea level. So you can work that out. You can divide. I don't know what that is in meters. I'll have to do. We'll have to do that another time. But you've got to climb to a place called Peacevale, halfway to Maritzburg, which is close to 3,500. There's no other way. You've got to climb 3,500 and then gradually descend to Pietermaritzburg again. So without money for tunnels and bridges, these railway lines just wound around hills. And as I say, 35 miles in straight line distance. Your mom used to say, as the crow rides a bicycle. In straight line distance becomes 88 miles on rail. It didn't have to. It's just because they didn't want to spend on digging tunnels, building embankments, and building viaducts. So eventually there were viaducts. They're in place today. I remember them being built. Most of them were built in the 50s and 60s between Durban and Maritzburg, and they're very nice viaducts and tunnels, and they shortened the line a lot. But and the very first railway was loaded. I think from those steam trains back to Durban, it was probably from Durban to Pietermaritzburg. It was probably about a 5-hour trip. You could say 10 miles per hour average speed, if that, maybe even longer. But that was blindingly fast to the settlers at the time, because the next alternative was a horse-drawn post carriage, or stagecoach, yeah, that sort of thing. Those were, the average was about, I suppose, double walking speed, although they very frequently went at 10 miles an hour, 12 miles an hour. And then the next one after that was ox wagons, which averaged 12 miles a day. So railway to early settlers was blinding. It was like Concord today. So, it's one of the reasons why our railways are behind, is they didn't really have much to compete with for the first 100 years. My mom's uncle Bernard he ran a wagon transport business. He plied the route from Algoa Bay to Bulawayo in then Rhodesia. Algoa Bay is now called Kabeja. It was Port Elizabeth. And you didn't, if you worked ox wagons, you didn't get taken seriously unless you worked from a port, because ships were a big deal. And he started his business about 1880, and he continued with ox wagons until he retired. It made his money, and he was too old to work any further in about 1935. And he said he was going to retire then anyway, but it was at that point in 1933 or 1935, for the first time, that railways got faster than his ox wagon. 1933. So he had a 50-year run competing successfully against railways. So that in part explains why we've never developed. We're never serious about competition anyway, because that's just the way they were. They were very lazy, and we didn't have a high density population, so there wasn't a huge amount of passengers to carry. And then, that's why a passenger just became it never made money, so it was looked down upon by the engineers as a loss-making nuisance. And so there was no desire to really excel, and that's why they went for leisurely comfort and kind of semi-luxury on our trains. They were very nice from that point of view, but you never got anywhere in a hurry. Anyway, to return to the technology, of course, with the road between Pretoria and Johannesburg got saturated, and roads take a lot of real estate to build. The M1 by that time had reached 3 lanes each way, And then it became necessary to do something about it. And so Sam Shilowa, who was in the ANC at that time, came up. He must have had an engineer speaking in his ear or something like that. But he suggested that they build the Gautrain. He was not in the ANC long enough for it to see it actually start, which, as you remember, was in the FIFA World Cup. I think the Gautrain opened in 2010, just in time for the FIFA World Cup. But that was our first second standard gauge passenger train, the first being in Durban and Cape Town. And that averages 160 kph. So operating speed is 160 kph, which of course is 70 kilometers per hour faster than what we can get, not what we can get, but what we do get on mainline when we have trains running, which at the moment is only the blue train. It's the only train we have running on mainline at the moment. 2 luxury trains, all we've got.
Right. And so can you just give like an overview in terms of the decades from 1965 when you were stoker on the railway through to present day of the rise and fall of the train industry and when was its real peak of shipping goods and really competing? Because as you said, we got over the ox wagons, but what was the kind of trajectory and what were the kind of dates along that timeline where it got really, really successful and then it started dropping off to the point where we've only got 2 luxury trains in South Africa?
Okay. Look, and when I was in the railways, which was 1966, Robin, your cousin Robin was born the year that I was in Empangeni. That was probably the height of railways in terms of how many miles of track we had. Certainly up until the 70s, we had, railways was ubiquitous. It was everywhere. Very useful and very technically good given the fact that it was 3'6" Cape gauge. And one of the reasons for that was that the nationalist government, when they built railways, they wanted to ensure that rail got used. And so you had to have a permit if you were purveying goods of any kind. You had to have a permit to purvey anything by road, and that ruled out anything but perishables. So your vegetables, fish, that sort of thing could be taken by road, although it actually wasn't. There was a fish train from Cape Town to the Reef, which was the fastest train we ever ran. It was for years and years. It was the fastest train, and that's because it didn't have any stops. It wasn't really, in terms of today's kind of technology. It wasn't really a refrigeration train as such. It was a cool train in the early days. All of the wagons were built with double walls of wire mesh with ground clinker stuck into it. There were water tanks on the roof with little ducts which dripped water through the clinker. And as you know, evaporation produces cooling. And I can tell you that those coaches riding through the Karoo, the idea was to keep that train going so there was always a breeze. Those wagons they did freeze inside in winter, not in summer, but they got very cold in summer. It was very effective. So meat could go by train. Fish always went by train between Cape Town and the Reef. There was no fish train between Durban and the Reef. But yeah, the 70s, I suppose, was the peak. At the time that I was in the railways in 1966, there were 116,000 employees in South African railways. That didn't decrease much into the 70s. And then, of course, there were still agricultural lines, branch lines bringing sugar, maize, all that kind of thing, fruit. And then in 1994, when the ANC took over, one of the first things they did was to deregulate the railways, which sounds very fancy, but all it meant was that you no longer had to get a permit to carry goods by road. And it was at that point that our railways was at its best. And if, every railway man in South Africa agrees with me. It was a mistake to deregulate. We would have had all of our railway infrastructure would be in place. What we've got now is roads with never-ending maintenance, never-ending potholes, and an average traffic speed of Durban to the reef is average traffic speed of 18 kilometers per hour for trucks. It's so jam-packed. So there is a a peak somewhere about say 1975, at which we also had many mainline trails. We had a mainline train to each port city: East London, Port Elizabeth, Cape Town, and Durban. And also in the late 1960s and 70s, we built as public-private partnerships. We built two major ore lines, one from Sishen to Saldanha, which is about 800 kilometers long, and that's purpose-built for carrying manganese from Sishen to the manganese port at Saldanha, a bit north of Cape Town on the west coast. The other one we built was from the coal fields in Mpumalanga, which was then the Eastern Transvaal, and that winds down through northern KwaZulu-Natal, and there's a bulk terminal at Richards Bay. And those were built in the 60s and the 70s, and they are very effective. Not today. I mean, Richards Bay, that line is getting a really bad rap at the moment because all of our bulk terminals in all of our ports are dysfunctional. Not dysfunctional, but underutilized. They haven't been well maintained, and the main culprit is trucks. The Durban and Cape Town and Richards Bay are all jam-packed with trucks that can't move. They were designed as rail ports, but what happened was that a train would draw up next to a ship and it would creep. And it's too much to describe how it works now. Some of them picked up whole train wagons and dumped them, their load, picked them upside down, dumped them onto the ship. Basically now it's all conveyor belts, but a train creeps along a ship, and in a couple of hours the whole train is emptied into the ship. There were no trucks involved. And in fact, I'll go as far as to say, where you see ore on trucks, there's corruption happening. Doesn't make sense.
Yeah, I think we can get into that a little deeper, maybe on the next one. I just want to chart the change of the railways, if you don't mind. And
Yeah.
can you recall from 1966, when you say it was like kind of getting at its peak, when did it start to change from steam into diesel? And do you remember the train models that came in that were diesel from the beginning? And how much of the production of making those things was in South Africa at that time?
Okay, the big changeover into diesel started happening in the 60s from steam. And they bitterly regretted it. 10 years into the program, they were thinking of returning to steam. And the reason for that was South Africa had sanctions because of apartheid. And diesel is very expensive on foreign exchange. And we, under sanctions, didn't have enough foreign exchange to pay for diesel or petrol. Eventually, there was a shady, if you like, shady, or unofficial or secret deal made with a friendly regime, which I think was Saudi Arabia, but I'm not sure which Middle Eastern country it was, whether it was even Iran or Kuwait. I have no idea. It's all changed since then. But we managed to secure a supplier from one or other Middle Eastern country. But as I say, in the mid 60s, they nearly did an about turn and returned to steam because we've got several centuries of coal sitting underground. And we currently export it. We've tried to export it because our terminals are not working well, but China buys most of it. But there's no shortage of it. And one of the strategies that the nationalist government was considering under sanction was to return to steel and to steam and stay on steam so that we didn't need to depend on oil. we had of course, Sasol's origin was in World War II. Sasol is a plant that makes oil from coal, and they learnt that technique from that technology from the Nazis. And so that was a strategic industry as well, was Sasol, was to try and get petroleum or petrol or various petro products out of coal. And we've still got Sasol, still doing that and other things, but it's Sasol these days has branched out to producing more of the kind of petrochemicals that are used in plastics production and other things like that, rather than just fuel. And but anyway, like I mean, when we got to 1974, that's when OPEC became the first oil cartel, and that's when the panic set in. OPEC in 1974 it was the first time there was an oil cartel, and we had oil shortages. Um, it's just before you were born. But even up until you were born, we were having to go, there were speed restrictions all over South Africa for cars. We couldn't, for example, travel, from Maritzburg to the Reef. We weren't allowed to go more than 80 kph. There were laws in place to prevent speeding because the slower the speed in a car, the less petrol you use per kilometer. And so there were all sorts of measures and panics, under apartheid with sanctions in place. It was a huge governmental panic, and they had to come up with a strategy. And the other thing was, apart from OPEC, the other thing was that the sanctions affected diesel in the sense that we bought the tenders were. I don't know when the tenders were negotiated. Possibly even before OPEC. I don't know, but I doubt it. No, it would have been. It would have been before OPEC. So what we had was a lot of diesel locomotives, and we had an infrastructure of our own where railways was training our own diesel fitters, and so we could do our own maintenance. But with diesel, the sanctions were interfering with that because the parts had to be from General Electric, which is whom we bought our diesels from. We bought from America, and I think that tender was negotiated before OPEC, and possibly at about the time that sanctions were becoming a thing. So they hadn't foreseen a problem. They had never foreseen sanctions, and so now we had a problem where we had the infrastructure to maintain our own diesel locomotives. We had our own diesel fitters, and the railways trained their own. But there was still a problem getting parts from overseas under sanctions. Whereas we had very good locomotive workshops for building and maintaining steam locomotives. We were building our own steam locomotives from the early 1900s already. So as I say, that was another thing. That was a problem with electric and with diesel, is that we were building our own electric locomotives in the 60s, but it was about 90% or 80% local content. The actual traction engines that drove the wheels had to come from, in that case, it was Metropolitan Vickers, which was an English company, but there were others in Europe and France as well. But we didn't build the traction engines. We didn't build the electric engine. So that was one of the disadvantages. One of the advantages of steam is that we were totally self-sufficient with steam. We had ESCOR already, which was we had our own steel. We had our own steel engineering, own steel producers, and we could actually build steam locomotives from the ground up under sanctions. But it was difficult with diesels. It was a problem with diesels than with electric units. But as I remember it, I mean, the peak of our technology in railways was in the 70s. And one of the reasons for that too was that we got very good. Our technicians got very good at building very, very comfortable mainline rail. It was marked. I remember in the 70s, it was like chalk and cheese. I took a mainline trip in the early 70s, and it was before welded rail. and I'll explain welded rail in a moment. And it was before welded rail and after welded rail, and it was welded rail, was noisy and sorry, non-welded rail with the joints was noisy and bumpy. Okay, so when they would join two rails, they join them with what they call fish plates, just four bolts, two bolts in each end. Those rails flex like this with the wheels going over them, and so you get a bumpy ride when you sleep, and also you get those clicks happen for the whole duration of a journey, and it's very fatiguing. And then they've developed these welded joints, which expansion joints, which where you could weld rail, you could weld rail for sections of up to a kilometer, and then the junction of the rail wasn't a fish plate with bolted straight on end by end like that. It was a flange. And so instead of going kak, 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 you'd get a kind of, I suppose the consonant would be an N or an M. It'd go mim, 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 rather than kak, 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 kak. And even then it was a mumble. It was a mumble rather than a click. And in the 70s, we suddenly got rail travel got very, very comfortable. The problem was it was no faster, but it was really civilized. I was astonished when I went to Australia to ride on their railways when I went in 2012. They've got horrible track. I was appalled when I got to England in 1980, having been there in the 60s, but the track had not improved. It was lurchy, noisy. It was good in the first place because of being standard gauge, but English track was noisy and lurchy. Australian's the worst I've been on, and in the former colonies like Cambodia, Laos, Vietnam, Sri Lanka, um, those were all either meter gauge or Cape gauge, which is only 3 inches different from one. And those are terrible railways these days. There's YouTube clips of people riding on Cambodian railways and Sri Lanka railways and East African railways, although Tanzania's now got a standard gauge train. But those were never maintained. And there are pictures of Congolese and Tanzanian railways with guys literally jumping a foot, uh, 50, 30 to 50 centimeters up and down in their carriages. It's hell. And we didn't do that. We had really good, what they call track permanent way. They lay permanent way. We had really good track engineers, and we developed some of the technology that goes into maintaining track like that. And what it does, they call tamping machines, and they are very long yellow machines that creep along the railway. They've got arms that dig in the teeth that pack the ballast. They lift the whole rail, pack the ballast underneath, and then relay the rail and straighten it as well. And so our curves became very graceful. They didn't lurch within the curve. We got really good track in the 70s. It was startling. It was chalk and cheese. So we had a combination of welded rail and tamping technique that we had imported and developed some of. And our main lines became very, very superior in terms of comfort from passengers' point of view.
So
Good.
I'm just I'm curious curious as to if you can remember any of the model numbers of the diesel trains that first came in and were adapted, and also if we were importing them in during sanctions, was a lot of the adaptation of those railway wheels to Cape Gauge done in South Africa, or was that part of an order and they were made to fit before they were shipped out? Do you know how that worked?
Yeah, they were made to order in various companies. Our predominant suppliers were Krupp in Germany, North British Locomotive Company in Birmingham, various Yorkshire, like Hunslet was one. Um, North British was in Birmingham, and Baldwin in the States, um, and they were made to order. And for example, mistakes happen. I fired a GEA, which is a Garrett locomotive, a double engine, and It was designed to be fired with mechanical stokers, but they they produced the locomotives. It was shortly after the war, and we needed them. So they produced and sent all the locomotives, and then they fulfilled the order for the mechanical stokers, which I will explain the workings of in a moment. And they sent that later, and when they arrived, none of them fit. They were 2 inches too short or too long. Now, that's a calamity because a mechanical stoker is basically a great big Archimedes screw, which forces coal from the tender through a pipe about, say, about a three-quarters of, no, about half a meter diameter or more, and it forces the coal onto a table in the firebox where steam jets spread it all over. So it has to fit. There's no leeways. I mean, when those were made for the GEAs, they all arrived fully made up, and they couldn't fit in the locomotives. And there, that became a law case, and it wound on for years and years and years. And GEAs never got mechanical stokers, and they were very heavy on coal. And so, on the Maritzburg to Franklin line, they employed two firemen on that line because it was all hills. It was 110 miles with three hills, up, down, up, down, up, down. Three hills, taking 110 miles, and it rose. Those hills were a couple of thousand. They were mountains actually. They were mountain plateaus. So it was hell of hard. The first upgrade from Maritzburg continued for 29 miles, which is about 40 kilometers, without a break. And I mean, that's very, very hard work on a fireman. That's why they hired two firemen eventually for that. Then talking about when the diesels came in, I was never interested in diesel electric locomotives, so I can't remember what class designations there were. The earliest one that I can remember, I think, was a 16D. The 16 class, I think, but I really don't know anything about diesel electric. Electric, I do know about because electric electric power came to various places in South Africa before 1900. Cape Town to Muizenberg, or just short of Muizenberg, was already in place in 1895. It was electrified. And Natal Main Line was electrified from about 1910 or 1912. And the first class of locomotive that was introduced in Natal was the Class 1E, number one. We went up. Currently, our main of electric locomotives have reached Class 24, I think, over the years. But the most common class ever that was produced was a 5E, which was then reclassified 6E with several modifications. And then the 6E was reclassified to an 18E with further modification. So they basically used the same chassis throughout since the 5Es were introduced. I remember the 3E and the 4E. I don't remember the 2E. I remember the 3E and the 4E. Those were kind of very large locomotives. 3E was nearly twice the length of a 1E. And electric locomotives are classed in terms of Bobos and Cocos. A Bobo is two sets of four wheels on a four-wheel bogie on each end with powered wheels, and a Coco is three powered wheels on each end, six driving wheels altogether. And that's still the same these days. All of our locomotives are either Bobo or Coco, but we haven't had a Bobo for many, many years. The 18Es were the last Bobos. You could say 5E, 6E, or 18E. They were our last Bobos. Now you only get Cocos everywhere. And the other difference technologically between, a huge technical jump in terms of locomotives is on the Sishen Saldanha ore line and on the Ermelo Richards Bay line. It was the introduction of AC current rather than DC current. And we have mixed voltages. I mean, The Sisson-Saldana line works predominantly on 25,000 volts AC, but the Richards Bay coal line was working on 50,000. And then on our main line between Durban and the Reef, sorry, Cape Town and the Reef, there's several different. Most of our locomotives, electric locomotives, work on 3,000 volts DC, direct current. But they did introduce 15,000 volts AC, 25,000 volts AC, and 50,000 volts AC on various main lines. I think the PE line also had AC and DC mixed. And they developed locomotives that could cope with both, or either or whatever. We even have locomotives that are both diesel and full-time electric. So when the electricity goes, they can carry on with diesel traction. But basically a hybrid of a diesel powering the traction. We've got all of those, and they're all designed here. But yeah, those are the chief changes. So the chief technological changes were the track and the different traction. The wagons haven't changed much. Goods wagons have changed a lot, but passenger coaches didn't change a lot. Not very well developed in South Africa. Much the same as they were 100 years ago.
Yeah, absolutely. Okay, so I think that gives us a really good idea of the changes over the years up until 1994 that you said were really a peak, and then on from that, um, some of the information as to where they are now.
Yeah, okay, one by one, they started. South African Railways had a weird marketing department. They talked about streamlining services. I mean, that's a second language person writing like that, because streamlining, you know what it is. It's making a smooth surface that doesn't interrupt wind. But what they really meant was rationalizing services. Sometime in the 70s, for an example, the Transnatal, which went between Durban and the Reef, was a nightly train, 7 days, 7 nights a week. The Transnatal was 3 times a week. The PE train was 3 times a week. East London, 3 times a week. And they started rationalizing those. And what they meant by that was they were cutting trains, making cuts. And there were various aspects to rationalizing. One was that they cut down the number of trains, the frequency of the trains, so that eventually, sorry, I'm wrong. PE and East London had trains every night, as well as Cape Town, as well as Durban. And then they cut a couple of trains per week from each of East London and PE, and then the Transkaroo, until they were running 3 times a week, like Sunday, Wednesday, Friday kind of thing, whatever. And eventually, from 1994, as a result of building really, before 1994, in both Natal and in all the existing provinces, but more particularly Natal was the best, but also the Western Cape, which was then the Cape Colony, if you like. They had really good highways, freeways and highways, and that really left passenger train in the dust. I mean, even for commuting. So people started getting cars left, right, and centre, and rail never recovered from that, because it was a 7-hour drive from Durban to Johannesburg easily in a car, and even a small car. And train was 14 hours. It was a 16 to 18-hour drive in the early days between Joburg and Cape Town, and 26 hours by train. And I mean, late, before the rise of the trucks on the Cape Town road, most people could get to Cape Town from Joburg in 14 hours. I did it in 10 and a half hours with Richard Lyon, at the height of the condition of the roads and the scarcity of trucks. But since regulation and the trucks have now taken over from the railways, driving isn't much fun anymore. And we would still have mainline trains in South Africa purely because they're safe and they're comfortable. Especially if we could have made a few technological changes. One of which I will mention, and that is that we could have emulated the fish train and the container trains by putting air brakes. Currently, all trains have air brakes, but only the ore trains. But the fish train had air brakes for the last years of its life, and that upped their speed limit to 120 kilometers per hour, because trains are a problem when it comes to stopping. They can safely do 120 on the bends, that's not a problem. But stopping a train is a nightmare on our main technology, which is vacuum brakes. Vacuum is it's a meter wide tub. Inside it's got a great big disc made predominantly of lead, coated with copper, or something very heavy, coated with something very strong. It's a plunger. And the locomotive produces a vacuum, and the vacuum is produced right throughout the train. You've seen these corrugated hoses that clip together between the wagons. Those are vacuum tubes. And what happens is that the air is sucked out of those tubes, and these plungers, which were about nearly a meter in diameter, then get sucked up to the roof of this tub that they are in. And attached to them is a lever, which then draws the brake blocks off the wheel. If there's any air introduced into the system, that plunger then collapses and the brake blocks go on the wheel. Very primitive, but very low tech. But there's a brake block. There's 2 brake blocks on each wheel in a buggy. So it's quite effective. It just isn't as effective as air brakes. But those vacuum brakes are very old technology, and they were, to give you an indication, they were dumped by Japan Railways in 1914. And we still use them. The Blue Train might have air brakes by now, I don't know. But the Rovos Rail has vacuum brakes. Zimbabwe Railways, all of the other railways in there that are not new, so they use vacuum brakes all over Africa. And they're very low tech, which is cheap to maintain, but not effective. And that's one of the chief reasons why they limit the speed. If we had put in air brakes, we would have had travel that was not competitive with car travel, but it would have shaved 20% off the times, but making a lot of people stay on train travel. You could have got to Cape Town in 20 hours, which was 2 hours more than driving it, but you didn't have to drive. So, that was a lost opportunity, keeping vacuum brakes on. Now, what happened just at the end of mainline travel, just before COVID broke out in 2021, every brake block on the Transnet system was stolen overnight. There were no brake blocks in the country. None was ever found. Nobody was ever arrested. Nobody's ever been brought to book. And all of the mainline trains were halted by the National Rail Safety Regulator because you don't have brake blocks. When I tried to make a train booking shortly within COVID, about a year after lockdown, by then the person on the other end of the phone told me that lockdown was what caused the cessation of mainline travel. Not true. It was the theft of brakes, and they've now whitewashed that because they haven't caught anybody. And we know that bigwigs were involved in the theft because only an inside job can get away with. And we were talking 200 tons of metal. It's a trainload of brake blocks.
Yeah. So I think in a later episode, because I'd like to return to South Africa, but in the next episode, what I think would be pretty good, and what you've kind of been touching on, is your experience with other railways around the world.
There's one thing I need to say about Cape Gauge before we leave that subject, by the way.
Yep.
And that is about Australia, which I said has always been a bit behind us in terms of rail. Um, they, I'm talking about speeds, I'm talking about performance, but they have the fastest regular mainline service on Cape Gauge in the world, which is between Rockhampton and Brisbane in Queensland. Queensland Rail operates tilt trains at around about 160 kph. So that's basically the fastest Cape Gauge service in the world. Japan runs Cape Gauge at 130 kph, but Australia runs Cape Gauge on the east coast at 160 kph, and it's viable. And but the thing of, just to give you an indication on the Cape Gauge service on Queensland Rail is actually the fastest train service in Australia. It should be standard gauge, but that's what I mean when I say Australia is behind in terms of standard gauge. They were also only interested in goods, and they've got amazing freight trains, following the American tradition, the American gauge, the American size, American power. They even have driverless goods freight trains on one of their mines, Rio Tinto. There's no drivers. They're very ahead on goods, but they run the fastest train in Australia is Cape Gauge. It shouldn't be, but it's remarkable and worth talking about, and that's why I mentioned it. But that'll be the last. I mean, we had a Cape Gauge test train, excuse me, which ran between Pretoria and Bloemfontein after we got our world record. They ran a train called Metroblitz, which used to run at mostly operate at 160 kph, same as Gautrain. They ran that between Pretoria and Bloemfontein, and they did that trip in 3 hours 52 minutes, which you couldn't do by car. And that's where we were at, and they just threw it away. They didn't. They got tired. They said, "Oh, we'll have to upgrade all the level crossings, and we'll have to upgrade this, and we'll have to upgrade the signalling." All of that would have been. But reverting back to Queensland Rail, here's the thing. Queensland, Rockhampton to Brisbane is exactly the same distance within kilometres as Joburg to Durban. We do today, if we had a train, it would take 14 hours to do that. Queensland Rail does it in 7 hours, 52 minutes on Cape Gauge. You know, why our railways didn't take that Metroblitz technology and adapt it to mainline trails, I'll never know, because it would have shaved 25% off all of our time. But no, they would have needed to actually, change the signalling. Just to dismiss that subject once and for all, if you're doing 100 miles an hour and your signals are laid for a train doing 90 kilometers, 160 kilometers, 90 kilometers, you come around a corner and a signal is upon you and you haven't got time to react. That's why signals have to be trained to accommodate speed. They have to be put in places where they can be seen by a driver from further away. But that's another subject, and that's another thing that changed radically in the 70s. But we can talk about signaling any other time you want to in the future, because that's changing right now.
Okay, well, I mean, that is an interesting subject, and I think something we really should get into. But I think we've been talking for a little over an hour, so I think we can draw this one to a close, and we can come back next week and have a look at another subject.